Next we move to the larger forms. This is a large tektite. This is 693 grams. Big tektites are always smooth. Bread crust tektites, this is 211 grams. This is quite typical. 200, 250 grams, very typical. As you get slightly larger, this is 350 grams, pretty smooth, but you've still got some degree of this polygonal cracking on the specimen. So you kind of get a transitional thing, 300 to 400 grams, kind of transitional, but above 400 grams certainly you're getting very smooth specimens. We call these spheres or nuclei. Large Philippine tektites are always smooth. At first when I started collecting, I wasn't really interested in them. I like these, but now I collect everything because you don't know how it's going to fit into the picture, and actually these are very interesting. You'll never get a big tektite that is grooved. I even collect the irregular ones, probably just fragments of larger specimens. Maybe we'll work out exactly how they fit together one day. And right, so large ones, two forms, perfectly smooth form, and then interestingly are these hamburger forms. Now at first glance you relate these hamburger ones to these bread crusts, but that's not right. We're measuring the original sphericity, the original size of the sphere. When we do that, and this is another one, I've got quite a few. We've measured quite a lot of these, and some are more convincing than others. That's a good surface there. You can actually get an impression of the size of the sphere, and what it turns out as is in a similar way to the bread crust being formed from the same size sphere as the biscuit form originally. These very largest ones were formed from the same size sphere as these hamburger ones. Hamburger ones are effectively the same as biscuits. They're oriented forms. The spherical forms, these were clearly rotating as they re-entered the atmosphere. They didn't actually re-enter as this though. What we also find are these shells, and these have bread crust structure on, polygonal cracks. So this is a shell. This is another piece of shell that's broken off, and here is another piece. These fit onto these bodies. Now this didn't come off this particular one, but you get the impression. They've cracked off of here. Now the reason for that is these very large specimens, there's a big temperature differential between the inside and the outside. These are thermodynamically unstable, so that results in this shell always cracking off, always leaving a smooth body. As I say, you never ever find a large bread crust. These small bread crusts, they're smaller, so not such a big heat differential between the outside and inside, so they're thermodynamically more stable, and therefore they're able to keep their shell. So when we come to other tektites, the other shapes, exactly the same. This is a dumbbell, not a great shaped dumbbell. Anterior grooved, posterior smooth. It's a very well formed dumbbell, this. Not such a well defined posterior and anterior, but there is some difference there. This is a teardrop. Again, it has a posterior and anterior, grooved and ungrooved side, and this re-entered like this. This is an even better one. This re-entered like this, and you've had this front spooling off. This is a very stubby one, very unusual. I only have 2 or 3 like this out of a few hundred kilograms, and this is re-entered like this, and again the anterior has spooled. This is an exceptional piece. I've only ever seen one like this. Shame it's broken, but This, as far as I know, is the only one in existence, certainly the only one I've ever seen. And this is a very, very, very large teardrop. And this is almost like a bread crust. You can see it re-entered like that. It was clearly oriented though. I mean, actually in many ways, probably not. You wouldn't classify it with a bread crust, you'd almost classify it with the hamburgers, because it was clearly an oriented specimen. Teardrops will always orientate themselves. Only a sphere can be randomly rotating as it's entering the atmosphere. Something that isn't perfectly spherical will always find an orientation, as this did.